All right, so welcome back. We are going to talk about functions in this video. So everything that we've done up until this point, we've been doing strictly in main. Main happens to be a function. It's always the first function that's called in a program. And everything we've done has always been just inside the function of main, and we've been going in just kind of a top to bottom manner with our code. We were always starting at the top of main, going to the bottom, never really jumping around in our code. And this works for short little demo programs, but it is literally impossible to create anything useful by writing code in this way. Okay, so we need more powerful structures and more powerful ways of handling our code in order to do that. And functions are the most basic one that is the most basic way of grouping our code together and making it so we can actually do something useful. Okay, so we're going to talk about that in this video. All right, so as I already said, main is a function. It's just the first function that's called, but we don't have to keep everything in main. We can define our own functions. All right, and most programming books and tutorials that I have seen, they always show you the syntax for how to create a function first, but I think that kind of puts the cart before the horse. I think it's more valuable to actually look and say, visualize what it looks like when we call a function in code. All right, so we have our main function here. Okay, and everything we've been doing kind of starts at the top and goes down. Well, at some point here, when we introduce functions, what we're going to do is we're going to do a function call. All right, we'll show you, or I'll show you the syntax here in a minute, but we're just going to make what's called a function call. And what's going to happen is at this point in the code, we're going to stop. And we are going to jump out to a completely different place in our code. All right, it's like we have a separate little block of code that we're going to define over here. And instead of continuing past this point, we're going to go out, run this code, but then come back and then keep executing on our way down. Okay, and we're going to do that. We're going to use these functions as our way of enabling us to create some reusable components that we can keep using again and again and again in our code, and it's going to make things a lot easier to read and a lot easier to work with. So if you look at these, there's a handful of reasons why we need these functions and why we create these things. Okay, let's put that down. Let's say why functions. Okay, and the first reason is to make code readable. Okay, so the basic idea, if you think about Windows, the operating system, estimates vary, but I think the number of lines of code Windows has is somewhere in the nature of about 5 or 50 million lines of code. It would be impossible to put all 50 million lines of code into one file and one function and have it actually do anything useful. It's just not possible. And so we have to be breaking code apart. We have to be putting it into groups that run at different times. And functions are the most basic way for us to do that. The second reason why we need functions is it makes code reusable. If I can spell today. Reusable. Okay, so a good example is, if you take a look, like up in this journal program, if I go File and then I hit Save, there's a block of code that knows how to take one of these journal files and how to save it onto disk. And the key is by putting that code into a function, I am able to say anytime the user goes File, Save, run that block of code. And now I can use that code as many times as I need to anytime the user does it. If there's some other place in the program that also needs to save it, I just call that same save function. And now all of the logic that goes into saying save this file goes into one place, and I can use it from anywhere, and I can reuse the exact same code every time. So that's the second reason you use functions. And the third reason, and an important reason that often gets missed, when first learning about functions is that it contains complexity. Okay, and what I mean by that is it takes complicated things that you have to do on a computer and it hides it down so that you don't have to look at it unless you want to. All right, so a good example of a function that is shipped with C and C++ and pretty much every programming languages, or pretty much every programming language, is sine and cosine. So sine and cosine, you give it an angle, you get the sine of that angle or the cosine of that angle back. I happen to pull up what the code for sine looks like. Okay, this I believe comes from the GNU C library. And if you really look at it, the function for sine actually starts here. And you can just kind of glance down at this, and hell, you can look at the entire file. This is all just to calculate the sine of an angle. Okay, I mean, not only are the algorithms to calculate sine on a computer complicated, but there's more than one of them. If you see here, it chooses, based on the angle you put in, it chooses a different algorithm to do based on what angle you give it. Okay, so to say that this is complex is an understatement. It is 300 lines of pure hell. All right, but the point is that if in your code you need to calculate the sine of an angle, you do not have to think about any of this. You do not have to care about any of this. All you have to care about is if you call the sine function with an angle, are you going to get the correct answer back? And the answer is yes. All of this complexity is hidden from you. Okay, and we're going to do that in our code as well. Like when you think about writing a program, if we were maybe writing our own journal program, at one point in time, we're going to write a save function that's going to go and be able to save things off to disk. And then once that's done, we're going to know that we can just call that save function anytime we need it, and we don't have to think about the complexity of it anymore. All right. You can think of functions are the point where you start to get a grasp of understanding how it is that software engineers are actually able to do what they do of building these huge, complicated systems. And this idea of containing complexity is the biggest ingredient, where on one day you're worried about the complexity of this, but you hide it behind a function, and then you go off and the next day you're dealing with the complexity of this area, but you hide that behind a function. And then you never have to deal with it again unless it breaks. Okay, so functions are the first thing that we do in order to do that, and we're going to look at how we define them and how we use them here. All right, so let's take a look. All functions have 4 parts. And you can define these different ways, but I'm saying that there are 4. Okay, the first thing that it has a name. All functions have to have a name because you have to have a way of referencing it. And in C and C++, we're just going to give it a static name that doesn't change. All right, so in the sense of, we use sine and cosine as an example before, and those are the names. SIN for sine and COS for cosine. So all functions, we have to give it a name. The second thing is we're going to give it parameters. All right, we will go over this in depth, but the basic idea is that oftentimes when you call a function, you need to give it something in order to do its job. So for example, sine is a great example because I can't call sine without also giving it an angle. Because if I didn't give sine an angle to calculate on, the sine function would go, great, like sine of what? I mean, you want me to return all this code, do you? What do you want? The parameter is stuff that you give to a function for it to operate on. Okay, and sine is just a great example. You have to give it an angle, and we can define as many parameters as we want on our functions. The third thing is that we need code, obviously, because if we didn't have code in our function, it wouldn't do anything. And then the fourth thing is the return value. And again, I'm going to keep beating this sine example to death here, but in our sine example, the point of calling sine and cosine is because we want something back, and that something that we want back is the sine or cosine of whatever angle we give it. And all functions can have a return value if they want. sine and cosine are obvious what the return value would be, but if you think more about the save function, if we think what would a save function want to return, you could have things like maybe you return where on disk you saved the file. So if you say save this file somewhere, it might return to you, I saved it here, and on the desktop under my folder. And but we get to define a return value. It doesn't have to be like a math function. We're always giving just back a number. We can decide what a function is going to return, and we can have it return anything we want. All right. So that's the basic idea behind how what a function has. Okay, so now let's take a look at defining a function. So I'm not going to use a complicated example, but I'm going to use an example that actually does something halfway useful here. Okay, so if you remember back from grade school, if you have 2 points on a plane, x1, y1, and x2, y2. All right, you can calculate the slope between those two as y2 minus y1 over x2 minus x1. Okay, and what I'm going to do is I'm going to define a function that calculates the slope of a line given 2 points that are on that line. It's going to take in 4 numbers, 2 for each point, and it's going to return the slope as a number. Okay. We don't need to keep that around. So let me first rewrite what the 4 parts of a function are. We have the name, we have the parameters, we have the code, and then we have a return value. All right, so I'm going to write this function out, and then we'll highlight what all the different parts of it are here in a second. All right, double, call it calc slope, double x1. Actually, no, I gotta. Double y1, double x2, double y2. Curly brace. And then we're going to say double xdiff equals x2 minus x1, double ydiff equals y2 minus y1. When we look at our function, we're saying y2 minus y1 over x2 minus x1. If x1 and x2 are equal to each other, then we're going to be dividing by 0. So let's handle that separately. We're going to say if xdiff equals 0. And I'm going to save myself a little room here by putting the brace there. I'm going to say return. Now I'm writing this NaN. NaN stands for not a number. It's a special value in programming that we can use. In C++, the definition for it is quite long, so I'm not going to write it here in the journal, but I will put it in Visual Studio when we switch over to that. But just know that if you type return NaN, it's not going to compile. All right. And then we'll say return ydiff over xdiff. Closing brace. Okay, so this is a function. And we can put this in our code. And if we put this in our code, at any point that we have 4 numbers that represent 2 points, we can calculate the slope by calling this function instead of doing it ourselves. Okay, so let's highlight all the different parts. All right, so the first part is the name. The name goes in a strange place in C++, but you'll get used to it pretty quick. the name goes right here. We have what's called a return type. We're going to get to that in a minute, but there's a return type, a space, and then comes the name of the function. All right, this should look fairly similar to how main was defined. With main, we defined it as void, and then main, and then an open and closing parentheses. You can see here similarly, we have a return type, the name, open, closing parentheses. It's just we have stuff in between our parentheses on this example. Okay, but the name goes right there. Next are the parameters. The parameters go in between these two opening and closing braces, or opening and closing parentheses. Okay. This right here is what is telling C++ what parameters we need in order to call this function. This says that we have 4 doubles we need to receive in order to do what we're doing here. We need a double that we're going to call x1, a double we're going to call y1, a double we're going to call x2, and a double we're going to call y2. It's just a comma separated list, and we're going to list them all out there. When you define a parameter, you are basically saying you cannot call a function without it. Again, similar to the idea of not being able to call sine without providing an angle. This is how we tell C++ you are not allowed to call calc slope without 4 doubles going in. All right, the third one is probably the easiest, is the code. That's everything here. So it should look, the style of it should look fairly familiar. If instead of double calc slope, if I had put void main, then this would just look like a normal C++ program, like what we've been doing so far. It's just code. It's going to execute in the same way, top to bottom, and everything goes the same way. The only thing that's different from what we've done before is that we have these parameters and we're using them right away instead of defining variables inside. All right, and the last one is probably the trickiest one. It's definitely going to be the newest one, and that is the return value. Okay, the return value of a function has 2 halves. The first half is going to be the return type, and I alluded to it before, but it goes right here, the first thing in the definition of a function. The return type tells C++ what type of value we are going to return when this function finishes executing. Okay, so in the example of sine and cosine, it's a double, obviously because we're calculating the sine and cosine of an angle. When we're doing this here, I'm calculating the slope of this based on 4 doubles, so obviously the slope is going to be a number, so this function is returning a double. I could return an integer, I could return a char, I could return a string. I could even choose not to return anything at all, and we'll get to that in a second. But the point is, we have to tell C++ the type, the data type, that we are returning out of this function when we're done. So that's the first half, is the return type. The second half is the return statement. All right. And you'll notice we have 2 of them. The idea is that when you're running a function, you go from top to bottom. The instant you hit a return statement, the function quits, and we return that value. Okay, so right here, I said return space, and then this thing that won't actually compile, but it will when we do it in Visual Studio. We return this not a number, and we say give that back to the user. Nothing below a return line that has run will actually run. Okay, so even though, in normal code, even though right after this if statement we would just go on to the next one, because inside this if statement is a return, the function quits right away. If our xdiff is not equal to 0 in this case, we skip this return call, and so we keep going and we hit another return value. All right, and in this case we return xdiff over, or ydiff over xdiff. The key to look at here is that whatever it is that we put right after our return, that is the value that's going to be sent back to the user. When I say that go out and come back and give me a result, whatever it is that goes here, that's what's going to go back to the user. This can be a constant number. I could return 5, I could return 10. This can be something that we calculate, like I'm doing here, xdiff or ydiff over xdiff, or it can even be a call to another function. So if I wanted to, I could put another function call here and say, whatever that function returns, return for me as well. All right. The point is, this return value can be spread across because you're going to have this return type here, and then you can have multiple return statements throughout your function. And when it hits the first one, the function quits. It goes straight back to wherever it was called from. I mentioned briefly that functions don't need to have a return value. They also don't need to have parameters either. Okay, so both of those are optional. So if I wanted to make a function that doesn't have a return value or parameters, it would look like this. So I'm going to have a return type of void. This should look familiar because we have been defining main with a return type of void ever since we started. If I don't want my function to return anything, I'm just going to say void. I'm going to give it a name, call it say something. If I don't want parameters, I still have to put the parentheses, but I'm just going to put an open and closing parentheses right away. All right, again, this should look familiar. This is how we've been defining main, but now we're creating our own. And so then in between the opening and closing brackets, I can do whatever I want here. It's just be aware that you're not going to have any parameters coming from the user, and you're not going to be returning anything to the user. So if I have a function called say something, I could say cout I'm giving up on you. And L. Okay, and this is a perfectly valid function. Oops, missed the L. This is a perfectly valid function. Anytime that I call say something, it's just going to print I'm giving out on you to the console, and then it's going to go back to the user wherever they called it. Okay. Let's see. Okay, so that's how we define a function. Define one with parameters and return value. Define one with no return value and no parameters. Now let's look at how we call one. Calling a function. Okay. I kind of had alluded to in my drawing earlier, if I have main and my code is coming down here, there's some magical thing called a function call which causes the code to jump out, go to my function, say do stuff, and then come back. Okay, this function call right here. The syntax for it is super, super simple. All right, all we're going to do, I'm going to use sign as my example because I don't have any other good examples. It's such a good function for describing what functions do. If I want to call a function, I can say double result equals, all I'm going to do is I'm just going to put the name of the function, sign. I'm going to put a left parentheses. I'm going to give it parameters. So sign takes one parameter, and that's the angle. I'm going to say 1.2. Close parenthesis, and then a semicolon to end the statement. Okay. What this is basically saying is that right here, C++ will recognize, I know what sign is. Sign is a function. I need to go run some other code. So as soon as it hits this line, it's going to take a break. It's going to go out to that sign code. It's going to take the value of 1.2 with it. It's going to let sign do its thing. And then when sign returns, whatever that value is going to get shoved in right here. Okay? All right, so if the sign of 1.2 happened to be 5, which it's obviously not, but if it happened to be that, then result would be set equal to 5. Whatever a return value of a function is gets put in place of the function call. All right, and it's, when you put it in context of sign, it kind of makes sense. This is how you would want it to work. You would basically want to be able to say, give me the result of whatever sign is. I don't actually want the letters sin, that. I want whatever this evaluates to, and functions allow us to do that. If I have multiple parameters, so if I wanted to call my other function, calc slope. Well, I'm not going to say that because I can't give it the same name. Just call it result2. I get to call my calc slope function the same way. And I can just give it 4 parameters because I need 4. So 1, 2, 3, and 4. Again, when I'm giving the parameters to a function, these can be anything. So they can be constants like I've done here for both of these. They can be variables. If you give it a variable, the value of that variable is going to be copied to the function for the function to use, just the value of the variable. I can have math things in here, so I could put, instead of 3, I could do 6/2, and it would evaluate to 3 and send 3 to the function. And I can even put other function calls in here. Okay, so if for any reason I needed to, instead of 3, I could put sine of 1.2 in there as one of the parameters. And if that happens, what it would do is it would say, okay, first I need to go and call sine, get that result. Whatever that result is, I need to shove it into the parameters of calc slope, let it go do its thing, and when it's done, come back and set the result into result2. If I want to call a function without a return type, there's nothing to assign that function value to. So all I'm just going to do is just put the name of the function, the parameters, and then a semicolon. Okay, so if I had defined that function say something and I wanted to call it, this is all I would do. It's just on its own line, just put the name of the function, open parenthesis, close parenthesis, and the execution will jump out, go say something, and then come back. And then execution just keeps on going as normal. Alrighty. The only other thing I will say, we also, here I said that if we have a function that doesn't return something, I can just put it on its own line. I can do that with functions that do return stuff also. You know, I can say sine of 1.2 here, semicolon. And C++ won't have any problem with this. It'll just take whatever the return value was, C++ will just throw it away. It'll say, obviously, it wasn't important to this program. Obviously, this wouldn't be very useful. The only thing that we're accomplishing if I do this is sending a computer into 300 lines of hell. But, you know, that's an option you can do. It's more frequent to do that than you would think because sometimes functions will return a value saying whether or not they were successful or saying what kind of outcome it was. And if we just don't care, then that's just what we're going to do is we just let the program just drop the return value and not care. All right. I think with that, I think that is a good point to say let's go ahead and switch over to Visual Studio and let's see what this looks like. Okay, so I already have a simple little program here. And all I'm going to do now, so you can see the similarity here if you look at main. You can see that main actually is a function definition. We've just kind of, in all the earlier videos, I was just like, all right, just don't look too deeply into it, just know that you need it. Well, now we can look pretty deeply into it and see that main, that's the return type of void. The name of the function is all lowercase main, and main, in our context, does not take any parameters. And then we put code inside it. And the only thing that's special about main is the first function that's called in every program. All right. So let's see. First thing I'm going to do is I'm going to go ahead and implement that calculate slope function that we did. Okay, so I'm going to put the return type. And then I'm going to put the parameters double x1, double y1, double x2, double y2. Put an open and closing parenthesis, or sorry, open and closing brace. And now I'm going to put my code in here. I'm going to say double x diff equals x2 minus x1, double y diff equals y2 minus y1. If x diff equals 0, we need to do something special. I'll get to that in a second. And then return y diff over xdiff. Okay, I said I was going to return not a number. In C++, intentionally creating a not a number in your code is a little annoying, but it's not too bad. It's just typing. So it's defined in this limits header file. And then I'm just going to say return std : numeric limits : double : quiet not a number. There we go. All that does, the NaN that I put, that right there is how you actually return not a number, or how you actually generate not a number. So the value that this is going to be returned by the function if you happen to send an x or two points that have the same x coordinate. And you'll also notice, if you take a close look, you'll also notice that this is actually a function. What we're actually doing here is inside this limits header file, we have a function called quiet NaN that you have to specify with a long prefix on it. And what that is actually a function that actually creates the NaN value and returns it to you. Okay, and so I can call this function. I can say, let's say double x1, double x2, double x3, sorry, y1, double y2, cout, enter y1. Let's do x1 first. Enter y1, y1. So to make this code a little bit more interesting, all I'm going to do is I'm just going to make it so that the user puts in the coordinates so that we can have the program calculate whatever the slope is based on it. Okay, and so now I can just say cout calculates or calc slope of x1, y1, x2, y2. Obviously it is not called that. What did I call my function? I called it calculate slope. All right, let's see if I can hide that to get it all on the screen. There we go. All right, so all I'm doing here, I have 4 variables. I request all 4 of them from the user, and then I'm going to pass them in. You'll notice that I'm having these variables, x1, x2, y1, and y2. These variables, the values are being copied into the values up here. Okay. These, it looks a little weird because I've used the same names, but how about I change them here? Let me say x1 input, 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 input. Oops. There we go. So the point is here that I have these 4 variables. The names of them, inside main, they're called x1 input, y2, x2 input, y1 input, y2 input. But as soon as I call this function now, the values of these are copied into new variables. All right, this fact that these parameters are separate is important. The fact is that when you start a function, you are starting with a clean slate. Everything that I have defined and used in here in main is not visible or usable inside my new function. The only thing that's visible inside my new function are the parameters I send into it. And the values that go in are copied into these 4 variables. Okay, so let's go and run this and see how it goes. Yes, I would like to build it. Hopefully I didn't make any mistakes. Okay, so it's saying enter x1. Let's start at the origin. And then let's say x2 is 10 and y2 is, I don't know, 2. And so this should say that the slope is 5. Or sorry, 1/5. Yeah, there we go, 0.2. Because we go up 1 for every 5 we go over. So it worked. So you'll notice here that what I did, when I called calculate slope, I did it inside a cout statement. All I did was I just said the name of the function, which C++ knows because I've already defined it up here, open parentheses, the 4 parameters, close parentheses. And what it does is as soon as it sees this thing right here, it says, hold on a second, I can't keep executing main, I have to go execute something else for a second. It jumps up here to this calculate slope, runs this code, and then once it gets the result, puts it back in here. Okay. What's nice is that I can call this function any number of times. So if I wanted to get the inverse of the slope, I could do that by just switching these around, doing just a little trick here, and reflecting this across the line y equals x. And I suppose before I should run it, I should just say, how about we say slope is, and then print it out, and then say inverse of slope is, and let it calculate it again. And now we're going to run this function twice. Okay, so I'm going to do the same thing, 0, 0, 10, 2. All right, now the slope is going to be 1/5, but the inverse is going to be 5. And it sure is. Slope is 0.2, inverse of slope is 5. There we go. Let me see. Let's do, really quickly, let's define a function that doesn't have any return values. So say something. There we go. So if I want a function that doesn't have any parameters, it doesn't have a return type, just put a void, put the keyword void, space, the name of the function, which is say something, and since I don't have any parameters, open and close parentheses as well. And now it says I'm giving up on you. You'll notice that without a void, there's no return statement. It's not necessary because it's just going to run top to bottom, and as soon as it's done with the function, it's going to come back anyway. But I don't have anything to return to the user, so there's no point in having anything like that. Let me see. One more thing that I'm going to do here is I am going to show how you can reuse functions and how useful they can be. This is something that we're going to do that would actually be very difficult to do without functions here. Okay, so what I'm going to do is I'm going to take all of this code that I just did, I'm going to put it in another function. Okay, I'm going to say void prompt for slope and calculate. When you're making your functions, you want to have descriptive names. Hopefully you're more creative than I am, because that's not a very creative name for a function, but you know, they say there's only two hard problems in computer science, cache invalidation and naming things. All right, and so all I've done is I've just taken all the code that used to be in main, I've put it in this void function so that I can call it a little bit easier. It does all the same stuff, and this function then calls the function calculate slope. And the reason I do this is because I'm going to go in here and I'm going to say in main, I'm going to say int selection, and then I'm going to say, well, let's do it this way. Let's go while true. Go into an infinite loop and say while true int selection, enter an option 1, say something, 2, calculate slope, 3, exit. And then I'll say, how about we put enter an option here down below the menu. So what I'm just doing is I'm making a common DOS style menu that we're going to present the user with and let them choose what our program does. We're going to say if selection equals 3, break. So basically we're just saying that if the user chose exit, they're going to break out of our program. Else if selection equals 1, we're going to, or no, 1 we said was say something. Else if selection equals 2, we're going to prompt, what was the name of that function? Prompt for slope and calculate. Let's just copy and paste it. And then if the user didn't enter any of that stuff, we're going to yell at them. Choose an appropriate option, you ignorant fool. All right. There we go. Okay, so what I've done here is I've just gone, I've decided that I'm going to say that there are 3 things that this program will do. It can either say something, it can calculate a slope, or it can exit. And as long as the user keeps on selecting 1 or 2, it's going to keep on doing those same things over and over again. If they select 3, we're going to break out of this infinite loop and the program will finish. And if they don't enter something that's 1 through 3, we're going to yell at them and let the loop go back through and show them the menu again. So let's run this and see how it goes. Okay, so it's showing me my menu. 1, say something, 2, calculate slope, 3, exit. I'm going to do 1, say something, and it said, I'm giving up on you. And then it showed me the menu again. Say something again. I'm still giving up on you. Do 2, it's going to calculate slope. Enter x1, 0, y2, 0. Let's go crazy and do something different here. x2, 5, y2, 5. Slope is 1, shows me the menu again. If I choose 4, it says, choose an appropriate option, you ignorant fool. And finally, I can quit the program by saying 3, exit. And as soon as I do that, it breaks out of the infinite loop and finishes. So the point of this program that I put together here is to show a halfway realistic thing that you would actually do with functions in order to make a program that has modular code and is reusable. Okay, so I just basically, obviously these menu options are quite easy and don't do a whole lot, but very often in your code, you'll make one function call that will start a cascade of an enormous number of things that have to happen. And by putting it all behind a function, you are containing the complexity and making it easier for people to read and reuse your code. All right. So I think that just about does it for an introduction to functions. You are going to see these things all over the place. We are going to use them ubiquitously. Take your time, whatever it takes to get used to the idea of using functions and being comfortable with them. Take that time and do it because it will pay dividends later. You need to be able to understand these and you need to be able to use them all the time because you just can't make useful programs without it. Next video, we're going to take a quick look at scope. We're going to talk about, it's an important thing that we've kind of been using already, but kind of pretending like it doesn't exist. In the next video, we're going to hit it square on and show you what scope is and why it's important. Using functions now, scope is hard to avoid talking about, so we're going to talk about it, and then after that, we'll get into recursion. Until then.